fire and water, earth and air combine into the matrix for growth. On a beach in California, soil scientist Elaine Ingham showed me the sacred balance that continually creates the soil.
This rock will become soil through the action of weather, wind, rain, and the microorganisms that grow on the rock. The bacteria, for example, growing on this will break this down. The lichens, the moss will grow on those bacteria, the phosphate fixed by those bacteria, and break it down into the constituent sand, silt, and clay that we're looking at here. The bacteria grow in there, produce organic matter, and on that the fungi then start to grow, contribute more organic matter to the material. Then along come the protozoa and the nematodes, and they start that process of nutrient cycling, which turns this into soil.
But that plant looks like it's growing out of solid rock.
Yeah, but you had to have just a little bit of soil caught in that crevice, and then the seed had to fall in there as well, and it's the nutrient cycling in that soil that allows that seed to germinate, start to grow, get the nutrients that it needs.
From barren rock to mighty forest is a long, long journey. Life eats away at the raw materials and binds them into a living food web. Millennia must pass before the soil is ready to support a forest community like this one.
So this is a forest soil, which I guess has taken thousands of years to evolve.
And it certainly has. We have to slowly but surely develop this from the things we were looking at on the beach.
But this isn't soil. I mean, this is stuff coming off the trees.
That's right. That's the organic matter that's coming down to the surface of the soil, and the organisms are going to decompose this material, turn it into the organic matter to build the rest of that soil structure that we're looking at. So let's take a little bit of a look in the soil, see what we can find. This food web in here has got just more diversity than almost any place else on Earth. Soil is where diversity really lies. We look above ground and we say, ooh, look at all the plant species here. And we go, oh, there's 10, 15 different plants in here. High diversity doesn't have a candle to what's here in the soil. We're looking at, probably about 100 miles of fungi per gram of soil, per teaspoon of soil in here. When we look at 1 teaspoon of soil, and so it's like that much, we're looking at 40,000 species of bacteria. We're looking at probably 20,000 species of fungi in that one.
These are species, not individuals.
Not individuals. Because now when we go to individuals, we're looking at 1,000 million individual bacteria split amongst 40,000 species. So it's a huge diversity that I'm holding right there in the palm of my hand.
I would have to say, that's a living organism.
Yeah.
That's alive.
Mm-hmm. It's a community. You can sort of think of this as New York City.